Our next guest is an accomplished flamenco guitar player, but that's not why he's here. Sorry. He leads the Peter Wall Institute that links community groups with researchers, ensuring that the academy is grounded in real needs. But he is a cutting-edge researcher in his own right, a professor at UBC whose focuses on our oceans. Our oceans have a lot of important messages to communicate. He deciphers what they're trying to say and relays this on to us. And the question is, are we listening? Please welcome a true friend of the public salon, Philippe Tortell.
One of the things that I've enjoyed about partnering with Sam and Lynn and also leading the Peter Wall Institute is learning that sometimes ideas that seem very disparate and disconnected can come together in unanticipated and sometimes almost unimaginable ways. And we make these connections for ourselves as we look around the world. And as you look at this image of Vancouver, we all have connections that we make, perhaps between the urban environment and the forests of Stanley Park, or between the mountains and the rivers and the fish. But a lot of what is really driving these systems is not visible to our eyes. A lot of what the real story is lies way, way beyond the field of view of this image. In fact, it lies thousands and thousands of kilometers beyond the horizon, where most of us don't venture. But as an oceanographer, I spent a lot of my life in some of the remotest places on Earth, trying to understand how the processes that happen in these far-flung places affect global processes. But I never really spent that much time thinking about how these large-scale ocean processes really hit home in a very local way. Until some rather extraordinary events of a couple of years ago really drove this point home to me. And that is the story that I want to share with you tonight. So it is a story about the oceans, but I'm going to start in a rather unusual place. I'm going to start the story at the top of a mountain, in particular at the top of two mountains. Now, those of you who ski, which may be a fair number of you, will realize we've just come off a fantastic season. You probably could still go up to Whistler and do some pretty darn good skiing at the moment. 2015, however, was a really different story. We had just a few diehards that pushed through uncomfortable significance just to say that they skied for the sake of it. If you looked at the oceans, though, this past winter and in the winter of 2015, you would have seen that those also existed in very different states. This past winter, we had what I would consider normal conditions in the far regions of the subarctic Pacific. That's the North Pacific, bounding Alaska and the British Columbia coast. The winter time there is not a very pleasant place. It's stormy, it's windy, it's huge waves, and it's very uncomfortable to be on a ship. In 2015, however, we had very unusual conditions. The winter storms that normally blow through the system were eerily absent. They were glass-like conditions, and in fact, they were the lowest wind speeds that we'd ever recorded in the last 60 years of observations. And to understand how these two phenomena, ocean conditions and mountaintop conditions, are connected, I need to explain something quickly to you about the way the oceans work. For our purposes, we can simplify the problem to thinking about the ocean as a two-layered system, much like the oil and vinegar that is pictured here. We have an upper layer of the ocean that might be just 100 or 200 meters thick. That's the part of the ocean that exchanges with the atmosphere. It exchanges heat and gases like carbon dioxide, and it sits over top of this deep, dark, cold layer that may be as much as 4 kilometers thick and is often isolated from the atmosphere for hundreds or more years. During normal conditions in the spring and summer, that surface layer warms up as it is impacted by solar radiation. And as we go from spring to summer and fall, that ocean gets warmer. But in the wintertime, those storms blow through and they reset the system. It's like you taking that bottle and shaking it and mixing it. All that heat dissipates down, and it's sort of like the air conditioner of the ocean. But in 2015 in the winter, when that didn't happen, it was like our air conditioner broke, and the net result is that we had this accumulation of a huge amount of heat in the surface. And this phenomenon became known as the blob. It was this area of warm temperature, something like 3.5 degrees warmer than the 30-year average. And over time, from December into the following year, that blob moved westward and affected the coastal ocean. And it had a number of attendant effects, sort of like dominoes knocking each other down in a chain. It obviously had effects on our marine ecosystems. The warm conditions changed the conditions for growth for marine phytoplankton. These are the algae that are the base of the food chain. And in particular, led to conditions that promoted the growth of poison-producing or toxin-producing species. Those toxins accumulated throughout the food web and led to an unprecedented number of marine mammal mortalities. But even if you're not that interested in marine ecosystems, maybe you're not such a fan of whale watching, the message still hits home, because what happens in the ocean also affects the land. And those warm temperatures in the winter of 2015 over the oceans acted to warm the land over top. And because we had unusually warm conditions in the winter, that precipitation that normally falls as snow in the winter largely fell as rain. And the result was that we had the lowest snowpack that we'd seen in many, many years. This is another one of these anomaly diagrams. The blue shows you the areas of the snowpack that were lower than normal over much of the west coast of North America. And that, of course, is what led to the poor ski season. But really, the ski season is just the tip of the proverbial iceberg. Snow really does a lot more for us than provide opportunities for recreation. In fact, snow and the accumulation of snow is fundamental to our hydrological cycle. It is really our way to store moisture from the winter that will nourish us in the spring and summer. And because we had such low snowfall during the winter of 2015, by the time we got to spring, there was really not much there. There was not much of a storage of that snowfall. And so when we got into this time of the year, May and June, when the rivers are meant to be flowing and the salmon are beginning to return, there's a real problem. The rivers ran unusually low and they ran unusually warm. And some of you may remember that we had a near unprecedented closure of the Fraser River sockeye salmon. This was a direct link, as was the death of the humpbacks, to these weird atmospheric oceanic phenomena happening thousands of kilometers off on the coast. Maybe you don't eat fish, but you breathe. And so if you breathe, you're concerned with air quality. You may also remember that in the summer of 2015, we had an unusually intense forest fire season that led to these dramatic impacts on our air quality through these aerosols and dust and smoke aerosols that came through from these forest fires burning very close to Vancouver. And so we come full circle here to understand that these atmospheric processes of the wind blowing over the subarctic Pacific can feed back through this series of dominoes to influence the very air that we breathe, that nourishes our lives and nourishes our bodies. And so as we look to the future and we think about our role as citizens of Vancouver, citizens of the world, we need to change our frame of reference. We live locally, we live meter by meter, we live hour by hour, and we think locally. Whether you're in a condo downtown in Vancouver where you're walking through Stanley Park, we tend to focus on our immediate surroundings in time and space. But that's not where the prize is. The prize is, the shift in the thinking is to think beyond that, to make those connections that aren't so far, to think that processes that happen that are seemingly invisible because they're occurring thousands of kilometers away in a region that you've never been to or never will go to. Those are the kinds of things that are going to really affect the way that we live in the coming decades and centuries. Thank you.